In this video, I'm going to use the method of Lagrange multipliers to find the optimum values of the function f of xy equals 2xy, subject to the constraint g of xy, which is equal to x squared plus 16y squared equals 64. So f of xy is always your objective function, and g of xy is always your constraint. Now, one of the techniques of using Lagrange multipliers is to create a Lagrange function. And in this course, we're going to use the Lagrange function, which was explained in my notes. So the Lagrange function, L of xy, L for Lagrange, is equal to f of xy minus lambda times g of xy. And I don't know why that's there. All right, so times g of xy. So in this particular case, our Lagrange function will be 2xy minus lambda times x squared plus 16y squared. And remember from my notes, you always subtract whatever is over here to the other sides to make that minus 64. And then let's multiply through. So we have 2xy minus lambda x squared minus 16 lambda y squared plus 64 lambda. That is our Lagrange function, simplified. So that's the first step. The second step is to find the partial derivatives of L, of the Lagrange function. So we want to find L of x. So that's the partial derivative of the Lagrange function with respect to x. So that's going to be 2y minus 2 lambda x, and then we set that equal to 0. L sub y, the partial derivative of the Lagrange function with respect to y, is going to be 2x, and this will be minus 32 lambda y, and we set that equal to 0. And then the partial derivative with respect to lambda. All right. Now, remember the shortcut that I explained in my notes is that that's always going to be exactly the same as your function g of x. So that's simply going to be x squared plus 16y squared minus 64 equals 0. Those are our three partial derivatives. The next step is to, let's do this in green, is to find x and y. So I'm going to start with taking the first, I like to go in order. Start with the L sub x, and let's solve that for lambda. So 2y equals 2 lambda x, or lambda is going to be equal to y divided by x. So we have lambda. The next thing we're going to do is I'm going to take that, bring it down here. So 2x minus 32, and let's put lambda in here, y over x times y equals 0, or 2x minus 32y squared over x equals 0. Now, multiplying both sides of the equation by x, we end up with 2x squared minus 32y squared equals 0. And let's solve this for x. So x squared equals 32y squared divided by 2. Or x squared is equal to 16y squared, or x is equal to plus or minus 4y. So we have x. There's two values of x, right? X is equal to 4y, and negative 4y. So next, we have to go to the third partial derivative, which is L sub y, and I'm going to bring that all the way down here, and I'm going to have to do some scrolling for x squared plus 16y squared, x squared plus 16y squared minus 64 equals 0. And let's substitute 4y in for x. So we have 4y squared plus 16y squared equals 64, or 16y squared plus 16y squared equals 64, or 32y squared equals 64. And then finally, y squared equals 2, so y equals plus or minus the square root of 2. All right, so the answers here have to be in decimals. So the square root of 2 is a decimal, rounded to one decimal place, is 1.4. So y is equal to 1.4 or negative 1.4. But as we're working with it right now, it'll probably be just as easy to keep it as in radical form and then change it to a decimal at the very end. Now, we technically need to go back through and do the same thing for negative 4y. But when we make this negative here, let's when I make this a negative 4y, I'm going to get the same answer. All right, so that means we don't have to really do it again. So now that we know what y is, I don't like that color. Let's go with darker green. We need to go back to what our x is equal to plus or minus 4y. X is equal to plus or minus 4y. And so we have x is equal to plus or minus 4 times plus or minus radical 2. Well, the plus or minuses and the plus or minuses are going to give us a bunch of plus or minuses. So x is equal to plus or minus 4 radical 2. And 4 radical 2 is going to end up being equal to 5.65. So this is going to end up being plus or minus 4.65. So our y values are plus or minus 1.4. Our x values are plus or minus 4.65. And rounding these to the nearest, I should have done that right at the beginning. 4.7, rounded to the tenths place. So that means we have 4 answers, correct? We have 4 answers. We have 4.7, 1.4, where they're both positive, negative 4.7, negative 1.4, and then we have a 4.7 and a negative 1.4, every possible combination of pluses and minuses, and negative 4.7 and a positive 1.4. So those are the 4 answers. Now, if you look at the question in more, it asks for the absolute minimum value of z at the point negative x, positive y. That's a key here that most people miss. Negative x, positive y. So we're looking for a specific answer. I'm looking for the negative x value and the positive y. So we're saying that there's going to be an absolute minimum at that. You need to find out what the z value is at that point and then identify this as being your point. Then it asks for an absolute maximum value of z at positive x, positive y. So that would be this one. And so you have to find the z value there. And this would be the x and the y value that you would have to enter. So the other two answers we're just kind of ignoring for now. Otherwise, there would be just too much information to enter, and I didn't want there to be that much information. All right, hopefully this was helpful. This is the basic methodology that you should be using for all 6 of the questions on using Lagrange multipliers for the homework. Regardless of the difficulty level of the problems, they are all accomplished pretty much the same way. You have to know what your, we want to know what your function is, what your objective function is, and what your constraint is. Make sure that you take the constraint, set it equal, so that's minus 64. Find your partial derivatives. Right down here. Find your partial derivatives. Once you've found your partial derivatives, start solving for x and y. Once you have your x and y, you put them together in all the various combinations, and then figure out the appropriate combinations to answer the questions. All righty.